Okay, good afternoon, everybody. I will try to keep this within an hour because I know I'm the only thing standing between you, lunch, and our tea time. So first of all, thank you very much to our partners at ORAC and for all of you. It's a privilege to be with you here today. There are a few updates with A2Ls, albeit I know there's still a lot of industry anxiety around it. For those of you who weren't present for the fall educational symposium with ORAC in September, if I'm not mistaken, this will be fairly new to you unless, of course, you've taken, say, the course at JTAC or perhaps a manufacturer's put you through it. Ultimately, we want to make sure you're a little up to speed. This is a bit of a watered down version simply because we only have the hour. Typically, it's 2 to 2.5 hours. We get a lot more granular. We get into some of the technical aspects, the system performance data and temperatures and pressures and what have you. We will cover some of that today, but ultimately we'll kind of jump right into it and make sure you have a good understanding of what's going on. Should have plugged my remote in here. So one of the first things we like to do is, why is all this happening, right? We know it's all in the name of the environment and it's save the trees and save the bees and all the rest of it. But at the end of the day, it comes down to the Montreal Protocol and perhaps more specifically, the Kigali Amendment to that protocol. So for those of you unfamiliar with what the protocol is, in 1987, I could only find the 1989 logo for today. In 1987, we signed the Montreal Protocol, and at the time, there were 62 signatories. Today, we have 192 globally, okay? But in 2016, we came up with a Kigali Amendment, which puts a spotlight on our industry. Okay, and part of the Kigali Amendment, and the reason why it puts such a spotlight on us is we've added HFCs to the list of ozone-depleting substances, whereas the protocol itself governs all things greenhouse emissions. So we're talking about buildings and infrastructure, we're talking about automotive, power plants, HVAC industry. It's kind of quite a large umbrella and an all-seeing eye versus that of the Kigali, which is a little bit more specific. But the Kigali is actually not a what, it's a where. But first, let's understand. So again, it's an amendment to the Montreal Protocol to help our ozone-depleting substances. Again, the where, it was adopted in Kigali, Rwanda in 2016. Not a lot of people know that. Everybody thinks Kigali is a what. It's actually a where. And the amendment adds powerful hydrofluorocarbons to the list. So 404, 507, 407A, C, F, 410, some of the A2Ls that you're going to be experiencing, all of which are on that Kigali amendment, okay? And a lot of people say, well, again, how is this transitioning? What do we expect going forward? So let's talk about the phase down schedule. I'm going to point your attention to the far right for non-Article 5 parties. So this is under the United Nations. And for those of you who don't know, fun fact, the Montreal Protocol, and by extension of that, the Kigali Agreement, is the first and only globally ratified treaty in United Nations history. So it's a pretty big deal. But we fall under the quote-unquote developed countries, okay? And what we do is we take a baseline of consumption from yesteryear, in this case about 15 years ago. And then what we do is we come up with a phase-down schedule. And the way it works is all the major chemical companies, Chemours, Honeywell, Arkema, Messer, whomever you can think of, they have a quota, how much they can import into Canada and how much we can make within the confines of Canada. You can recycle until your heart's content, but virgin gas, there are limitations, okay? So what they do is they reduce that quota. And what they've said in 2019, we're going to drop by 10%. So that's where we started to see some of that shift from, say, 404 or 507 in the refrigeration segment over to 448 and 449. 2024, 40%. That's a big number. So now all of a sudden, we start to see a lot more interest being paid to A2Ls. And ultimately what happens is as we reduce that quota, that supply starts to drop. Manufacturers start to pivot. Once they start to pivot, we start to see actual market changes that impact everybody in this room, one way or another. 2029, 70%. 34, 80%, and 36, 85%. That means in 10 years, 10 and a half years, you're going to see an 85% reduction of pretty much every gas you've ever known, loved, trusted, or ever used in your career, right? So it's a pretty big phase down. So to give you kind of an optics on that, here's the countries that are participating, and I hope with the sunlight you can still see that. These are all the major countries that contribute to the greenhouse emissions globally, but also have the resources with which to mitigate it, right? The yellow line is where we are, very, very aggressive, versus that of other countries. Now, you might notice there are two countries, I'm not going to say who, there are two countries that are pretty large in population and pretty large in terms of greenhouse emissions that are not on this list. I'm going to let you interpret that. Thanks, Steve. So they're not on there. All I'm going to say is I want you to think about how their government operates, right? Even though they're major contributors to the climate crisis, they're not going to be active participants of the protocol. The other countries that are on there, that are not on this list, may not be big contributors to the greenhouse emission problem, or they may not have the resources or the wherewithal with which to mitigate their impact. But either way, it goes to show you how much more aggressive we are versus that of a ton of other countries, including the one tariffs were put on that has nothing but penguins on it, from what I understood on the news. So, that brings us to what the United States is doing, the AIM Act, the American Innovation Manufacturing Act. It was written in 2020, and I'll preface this section with this. Canada does not have one piece of federally ratified legislation on A2Ls, period. Let that sink in. Everybody in this room is either seeing A2Ls come in, is installing it as we speak, or will have it imminently forthcoming into your companies, and you're going to start to see more and more and more of it, and yet Canada has no legislation written on the subject. But the United States does, and you got to appreciate why that's relevant. Think of all the major manufacturers, and I'm going to yell out a few because I don't really care. I want you to know. York, Carrier, Trane, Lennox. Guess where they're made? They're made in the United States. And the way the AIM Act is written is it actually limits or completely prohibits manufacturers directly from what they can actually manufacture in terms of what refrigerant goes in it if it exceeds a certain GWP or global warming potential, or it prohibits the export altogether. So Canada is going to experience the law as if we had written it ourselves, predicated on nothing more than where we procure it from, right? So the meat and potatoes of that, and for those of you at the back, I hope you can see it. You can't see it from up front? Did you go to your optometrist, Dino? Right on. Stationary residential, actually, you know what, before I get into that, let's get some definitions. So this is your industry segment. Here's your segment description and or criteria. You've got your GWP limit, and then you've got your respective enforcement date. Elephant in the room is at the top of the list, isn't it? Stationary residential, light commercial, air conditioning and heat pumps, and they get into a little bit of description here. Light commercial, mini splits, unitary systems, etc. That's rooftops. That's the entire residential segment. That's commercial splits. That's 60 to 70% of our trade. That's a huge elephant in the room. 2025, that's why you're seeing everything happen the way it is right now. That's why A2Ls aren't coming, they're here. Because the US stopped the exporting or the manufacturing or the manufacturing on Jan 1st of this year. VRF, same thing, little bit of a later date. Do we care? Not really. Daikin, MITS, Hitachi, LG, they've all shifted, they've all pivoted, right? I don't think they've come out with a legacy A1 gas in a couple of years, in fact, right? There might have been a couple of stragglers or somebody had leftover inventory, but they pivoted long ago. Refrigeration, an often omitted discussion point when we're talking about A2Ls. Everybody thinks A2Ls, and we are indoctrinated with two gases, R32 and R454B. How about the other dozen that are coming? And we're going to talk more about them because there are a lot more than you think. Cold storage warehouses, that also constitutes standalone units. They've put a provision in there. More than 200 pounds, 150 GWP. Less than 200 pounds, 300 GWP. Well, at 150, that eliminates about 98% of every gas on the ASHRAE list. There's not a whole lot left, and what is left, I promise you, you're unfamiliar with. Retail supermarkets, same thing. The only difference, they've extended it to 2027. 200 or more, 200 or less. So again, this is going to be very, very important for us to keep a close eye on. Now, full disclosure, Canada, we've been forgiven a little bit. We actually don't have legislation written on the subject. And think about some of the major manufacturers. M&M Carnot, L&P, Keeprite, Ref Plus, CanCoil, Cooljet, any of the major manufacturers you can think of, guess where they're made? Domestically. And if we have no legislation, this really doesn't impact us. Even if the components come in from overseas or from south of the border, we're going to be given a little bit of a cushion. And we'll talk a bit about what Canada's proposing. Just when you thought the fun was over, it isn't. Chillers. Pretty much almost everybody, and I know a lot of people in this room, I know you're in the chiller market as well. Fourth line down is going to be your big elephant in the room, comfort cooling, 700. Now, Canada does actually have one piece written on chillers. Our threshold limit is 750 in Canada. Now, you don't pick up any extra gases between 700 and 750, so it's not as if we gain something from it, and you'll see what we've proposed anyway to align with the US, so it's probably a temporary provision, but it is ratified, and it is a rule of law at the moment. The rest of them, majorly industrial process. For any of you getting into cryogenics, any of you getting into cascade or auto cascade, anything like that, you're going to fall up here. Still 700. If you're getting into ultra low temp, the US doesn't even have a provision written on it. And we likely won't either because it is specialty and it serves specialty marketplaces. When you're getting into industrial process, not using chillers, again, we bring back that 200-pound provision and a temperature range with which to decipher between 150 and 300. But again, on the low temp or medium temp side, we're not going to feel the immediate impacts of that. It's really the HVAC sector that we're feeling it, okay? This is a very interesting announcement. And for those of you who don't know, I try to keep up on this news, but for those of you who don't know, Lee Zeldin is the new head of the EPA. He's also a Trump disciple. He and his boss don't believe in climate change. And because of that, what ended up happening late last year, early this year, is the grocers associations down in the United States sued the EPA. And they said, you're forcing us to put in brand new technology into our new supermarkets. And as a result, that's going to have a lot of impact on our capital expenses. And we're going to pass that cost along in our broccoli, in our meat, in our corn, to the already suffering consumer. So Mr. Zeldin decided he's going to roll out a 31-step program. And he's going to either slow, stop, or reverse this train from the AIM Act. Now, subjectively, that train's already left the station for HVAC. Our VRF systems, our rooftops, our mini splits, our ductlesses, our chillers, it's done. It's already been shipped, it's here. Anybody here already installed A2L systems? Yeah, so at least half a dozen people already. So it's here. The train's already left the station. But arguably in refrigeration, it has the potential to be slowed, stopped, or delayed in some way or another, right? But I just wanted to share that with you because that will impact how we align with the US, okay? So more to stay tuned on that. Again, that was March 13th, so that was fairly recent. We're not too sure what they're going to do about it, but let's face it, we know there's some uncertain times down there, and as per recent events, anything is possible. So that brings us to Great White North. What is Canada doing? So on August the 9th of last year, HRAI was kind enough to furnish us all with what they call a draft consultation document. That draft consultation document is a result of HRAI, which acts as a conduit between trade and legislators, amongst a number of other attributes of HRAI. And what they do is they kind of poll the audience, right? We're talking to manufacturers, we're talking to wholesalers, engineering firms, consultants, contractors, everybody, with two goals in mind, mainly. The first, how do we align with Canada's climate accords? How do we stay on pace? And the second is how do we align with Big Brother, right? You can't share one of the largest borders in the world and have legislations like this. You have to have alignment, right? Again, a lot of that product is procured south of the border. So we need to have some kind of consistency. Much like the AIM Act, and much like the EPA, Environmental Protection Agency, we have the ECCC, Environment Climate Change Canada. They have the AIM Act, the American Innovation Manufacturing Act. We have ODSHAR, the Canadian Ozone Depleting Substances and Halocarbon Alternative Regulations. Say that 5 times fast. So, yes. I made that name. Yeah. Didn't exist before I walked in. This is our proposal for Canada. Now, for all intents and purposes, it's primitive. It doesn't really have good market segment description, criteria, albeit we have provided a date and a GWP limit. And the dates and the GWP limit, we do see some consistency. But even if you look and read the draft consultation document from last year, you'll see that there's calls for clarity. It's a must. So let's walk through a couple of them. Comfort cooling, okay, you know what? We can digest that. Commercial, industrial, residential, 2026. Again, do we care? Not really. We're already doing it. Half a dozen people put their hands up, and there's going to be a dozen by next month, and this whole room by September. So even though this is in proposal stage, once it's ratified, it's really not going to make a big cannonball, is it? We're already going to be pivoted and used to the new way. Where we need some clarity, I'm going to skip over computer rooms and data centers because that speaks for itself. Where we need clarity, chillers AC, chillers refrigeration, chillers. We've got 4 different variations of chillers. So it's arguable, and we can speculate all we want, but really it's important we get the clarity, right? Because this is going to be federal law. Chillers AC, commercial, industrial, all right, 2025. Well, we've already enacted something. So I'm still confused why it's on the proposal, but we're at 750. So again, remember how I told you earlier, we're going to try to align with the United States. They put 700 instead of 750. Chillers refrigeration, including ice rinks. Well, ice rinks are majorly industrial. Majorly. CO2 or ammonia. You might see the odd fluorinated plant, but really it's going to be more on the industrial side, and yet they've listed it as commercial. Then we do have industrial, and we've given temperature ranges, one of which is 2028, considerably further out, so a lot of process cooling. But either way, we need clarity not only on the description, but if we do stay consistent with the US, are they going to start putting provisions in terms of how much refrigerant you can have in the system? It's not on there. We need clarity. Standalone self-contained residential refrigerators. I hope nobody in this room services residential refrigerators. Dino applied at the Brick. You applied at the Brick? You applied at the Brick? Yeah. Yeah. Standalone, self-contained. Okay, so 2025. I'm going to come back to condensing units. Centralized or cascade? ORAC. Okay, 2027. Also consistent with the US. We've got food processing or dispensing, ice machines, mobile refrigeration, passenger vehicles. Anybody here who has a vehicle, 2021 or newer, you'll notice there's no more 134 in your vehicle. It's 1234YF. You've gone to an HFO, a hydrofluoroolefin, also an A2L. We get some more clarity down at the bottom. Medium-duty passenger vehicles, heavy-duty pickup trucks, agricultural vehicles, tractors, John Deeres, Conestogas, 18-wheelers, and all the rest of it. But ultimately, there's calls for clarity. Now, I've spoken with Perry Chow. He's the Director of Regulatory Affairs at HRAI. He speculates that we won't have an updated version of this proposal until later this year, if not early next. So again, this is going to remain in proposal stage for the foreseeable future, but it's still very, very important we pivot according to what the US is doing, again, because we're procuring the vast majority of what we use, what we work on, what we service, and it all comes out of the United States. For chillers, 750, as I mentioned, it's early enough in the year, especially because some of these manufacturers have 45, 50-week lead times, okay? It's early enough in the year that this may affect you. If you have a chiller on the way to Canada, if you have a chiller that has landed in Canada but has yet to be installed, if you have a chiller that's landed in Canada, has been roughed in, but you've yet to commission and start up, and it has 134 or 410 or any refrigerant that you've known in yesteryear which exceeds 750, you must get federal exemption. If you don't, there can be enforcement action brought against you. Now, arguably, because I don't think there's any government officials in the room, by a show of hands, how many people have had an environmental inspector on their job site? 0. So, you know, arguably, you're probably pretty safe, but it's important you do actually understand what's going on and what you need to be prepared for, provided this applies to you. If in fact it does, please make sure you have the latest rendition of the B5223. A lot of folks I've spoken to, both in and outside of this room, still have the 2018 edition. You must get the 23 because it has the proper provisions regarding A2Ls, A2s, and A3s. Okay, so make sure that's observed, and we're going to talk a little bit about the code in a little bit. So, index and landscape. So where do these refrigerants fall on it? Now, my program was acting up, so forgive me because R32 didn't highlight pink for me. But this is your list of some of the most popular gases out there, some of which you may be familiar with, some of which you may not be. Anything in blue, and I know some of you may not be able to read it because of the sun, 404, 448, 449, 507, these are your legacy low temp gases. Okay? Anything in green, 407C, 410, 513, and 513 is a little bit newer, but they're legacy air conditioning gases. They're also A1s. Anything in pink, though, are going to be our predominant leaders in A2Ls for both low temp and high temp. Again, 32 should be highlighted in pink. It's a race to the bottom. Everybody wants to be the lowest GWP there is. Okay? These lines represent some of the critical points, be it 1,500 in refrigeration for Canada, 300 and 150 for the US, what will be a forthcoming 700 for Canada in air conditioning. There's going to be some changes, but this is where on the GWP scale all these refrigerants fall. Now, for those of you unfamiliar with GWP, it's okay not to be familiar with it, what that actually is. GWP is a measurement of how much energy a pound of gas or a molecule of gas, we measure it in tons because it's a global phenomenon, but how much energy a pound of gas can trap if it's released into the atmosphere, right? And energy is a euphemism for heat. So if I release a pound of gas into the atmosphere, how much heat can that trap? How long does it stay trapped? And how long does it take to dissipate? And we do that using CO2 as a benchmark, which has a GWP of 1. Okay, ammonia, 0. R290, propane, 3. Considerably lower, but all natural refrigerants, right? So just a little sidebar on what GWP actually means and what it represents. What a lot of people aren't aware of is where our current legislation resides. We talk about the proposals. We know in air conditioning, again, we don't have very much, but in refrigeration, we do. And again, it's an often omitted topic. So, in Canada, 2,200 GWPs for racks or CDU, that's centralized distribution unit, fancy way for saying rack. 2,200 GWP is your limit. For standalone units, 1,400. And when that happened in 2020, that's where we saw 448 and 449. And for those of you in low temp, I know you remember when you went, what do you mean no more 507? What do you mean no more 404? That was when it happened, and they fall just below the mark. Quebec was a little bit more progressive, okay? If you are less than 50 kilowatt, and for those of you who prefer imperial, that's about 15 ton. If you're less than 50 kilowatt, 1,500 is your limit. If you are greater than 50 kilowatt, 150 is your limit. And you're going to notice two things as we move to the left side of that screen. The first is you're going to become more and more unfamiliar with what you see. 457, 466, 455, 454A, 454C. These are gases nobody in this room has used. The second thing that happens is they all turn pink. They're all A2Ls for the most part. Save that of R290, propane, and CO2 in the top right. And to contrast it, look at 404 out here in the wilderness, all by its lonesome, at 3,900 and some odd GWP. So we are really, really dropping the bar. And it's super important that we understand what gases are forthcoming apart from just the two that everybody has indoctrinated you with, because there is an entirely different segment. Here's a glimpse of those gases. This is going to kind of be the future. So you've got your ASHRAE designator, you've got your patent holder, composition ratio. So again, for those of you unaware, refrigerants are kind of like wine, right? We have a Gamay, we have a Cab, we have a Syrah, it's all mixed together. And in brackets, you'll see the respective percentiles. It's GWP, it's ASHRAE 34 class, which we'll talk about, and what most predominant gas it replaces. There's three gases on this list that stand out. The first of which is 454A. It stands out for two reasons. The first of which, 238, falls below the 300 GWP threshold. Now you might say, well, hold on, Kev, you said 150 if it's over 200 pounds, and you'd be right. But how many systems really, truly go over 200 pounds in refrigeration? From the greater footprint perspective, majorly. Not very many. So RACs do, right? You might have some really, really large facilities for sure, but you got to appreciate the lion's share of systems actually are under 200 pounds. And even those of which that are above, manufacturers are becoming very creative. We're coming up with rack systems or standalones, because it's possible to have standalone, where we dilute it over different circuits. One manufacturer, who shall remain nameless, has reduced their pipe diameter in their high-profile evaporators from 5/8 to 1/2 inch. That reduces the charge of that evaporator by 40%. So even manufacturers are becoming more and more innovative to make sure that you're under that 300, provided that Canada launches legislation that's consistent with the US, but thus making 238 a bit more attractive. The second reason is that most major manufacturers, the compressor manufacturers, the valve manufacturers, the OEMs that put all the machinery together, have approved this for use. I know two of which that are already rolling it off the production line in Canada. In fact, there's a facility right now just north of Saskatoon that's all operating on 454A. Major facility. The second gas is 454C. It stands out for two reasons as well. 148, now we fall under both thresholds. And two, it too has been approved by the major manufacturers. And for some, it's in the latter stages of beta testing, and for others, it's already rolling off the production line. The third is a bittersweet. The sweet part on 455 is it's 148, falls under both thresholds once more. The bitter part about it is we have 744, 3% of it in that blend. That's CO2. What happens to our glide when we add CO2 to our composition? It goes to the moon, right? And because I've cut out those technical slides, I can tell you right now, at 20 degrees saturated, for those of you familiar with glide, at 20 degrees saturated, 455 has a glide of 22 Fahrenheit. That's obscene compared to, say, 404 at 1 degree. Or a 134 that can run fully flooded and you've got less than half a degree. Or azeotropes like 507, also running fully flooded at near zero glide, versus that of 22. Now you might say, well, why is that relevant? Well, apart from performance inefficiency, appreciate the word fractionation. If you develop a leak and I leak out 10 pounds out of a 100-pound system, you've now changed that composition because the CO2 is going to leak out first. And either that composition is going to be no longer viable for use or run very inefficiently. And it's a very, very hard sell to your end users to go out and say, you have a 100-pound system, you leaked out 10, I need to change 100. That's a hard sell. So that's why we're seeing 455 take predominance in small pop coolers, upright reach-ins, glass door cases, condiment rails, and what have you. But it could, theoretically, because it's 148, come into the larger commercial market space. But this is what you need to be exposed to, and we'll talk more about this hopefully when we partner with ORAC in the fall educational symposium, because there's going to be some technical data on these that you get to have a look at. Just want to check our time here. Okay, we're doing okay. So very quickly, on the air conditioning side, 410, we know it's an A1, has a GWP of 2,088 versus the 700 that the US has moved to. So we're 2/3 from that. That's a far cry from what 410 is actually doing. Composition ratio, design pressure, very, very important. Couple things. Number one, you need to know it when you register your job with our friends at TSSA. And number two, who in this room has had the whole conversation about, do I use type L or do I use type K copper? I know all of you have, because I've talked to half this room when you're with your inspectors. And the fact of the matter is this is your benchmark pressures that you need to consult when you're actually deciding what copper you put in a system. The relevance to you guys, about a 30% difference on cost of materials. It's a big relevance. Right now, the way the law is written, not to go off on too much of a tangent, right now the way that the code is written, at 448 PSI, you're allowed up to 7/8 in type L. Suction or liquid, doesn't matter. The moment you go to inch and 1, you're going to need to use type K, specifically ASTM B819. However, at 422, for example, I might pick up an extra diameter. Now I get to go to inch and 1 in type L. We perform those formulas, and we all know, I all know you're guilty and until proven innocent on site. So, but this allows for you to save some money, especially if you're in a competing mode. If you're doing a bid job, this better positions you. Understanding, you can exercise regulatory knowledge to better position you for a job, right? Anyways, all that notwithstanding, LFL and UFL, I'm going to cover that in a lot more detail in a few moments. Lower flammability limit, upper flammability limit. Burning velocity, otherwise known as flame propagation, how quickly does that flame spread? Auto ignition, flash point. How hot does that gas need to get to combust? Well, at 648 Celsius, if you've reached that temperature, you're down a technician, right? So your building is melting. So when we say A2Ls are safe, we're going to prove to you just how safe on the flammability side of things, but it's very, very safe. Very quick point on efficiency and capacity. Anybody who's taken an A2L course, not a technical certification like JTAC is offering, which I applaud, by the way, because it's very, very important. But if you're talking to a manufacturer, they're going to tell you why the gas that they've chosen is better than the other guy. And they're going to tell you it's basically down to efficiency and capacity and a few other things, right? Have a look at a rooftop, for example. What have we done over the last 20 years? We've gone from recip to scroll, 22 to 410, copper tube and fin to microchannel. We've gone from constant volume to VFD. We've enlarged the surface area of the condenser for better total heat of rejection. We have made major changes to the way equipment is designed in the HVAC space, all in the name of efficiency and capacity. So full disclosure, yes, you're equal to and a little less than on capacity in 454, but it's marginal. And you do pick up a bit on 32, but it's marginal. And the fact of the matter is those mechanical changes, they made the real splash, to the point where everybody in this room pays, give or take, about $2,500 a ton in the commercial space. It's not cheap, right? And it's all because of these changes. Everybody remembers when VFD came in. Nope. This is why I do refrigeration, Greg. But we have a special on at Master, Greg. Buy one, get the second one for the same price. So what are the actual numbers? What does it actually look like? So coefficient of performance, between 3 to 8% higher on 32. You're doing a 10-ton rooftop, marginal. Okay? And you're slightly lower on 454B. The reason 32 has better thermodynamic properties. 32, just to clarify, is a 100% component. It has no blend, no glide. It loses no efficiency when you're operating within your system. So that's why you have better thermodynamic properties. Your cooling capacity is slightly higher. We can't put a number to it. Why? It's a variable. What condensing temperature you're running, what suction temperature, what's your TD, what's the ambient, all kinds of different things, right? So, but it is higher. And the reason, majorly, is higher volumetric capacity. It has better mass flow, as any 100% molecule would, in contrast to its contenders. SEER ratings, typically higher, but we're equal to on 454B. Discharge temp. Listen, this is kind of a bittersweet conversation. Everybody in this room has two goals. The first is to keep your system running healthily. We want the system to be healthy. We don't want callbacks. But on the other hand, I want that system to die day one after warranty. Right? So it's kind of a bittersweet, because 454B is much better on the compressor. It's less thermal stress. But when you're higher, it cacks. So chalk it up to a draw, right? Both of which help you. Lastly is the elephant in the room. 20% less than 410 on an R32 charge because of its mass. Its molecular mass is larger, right? Do we really care? Think about it. First of all, the manufacturer doesn't give you a choice of which gas you're installing. Secondly, 80% of everything you're putting in is pre-charged, unless you're adding line distance. And if you're adding line distance and that's what your extra top-up is for, it's marginal. But I'll grant you, yes, indeed, you could put 20% less gas if you had, say, a VRF system, or you had a very, very, very large chiller that isn't pre-charged. It's just nitro or a holding charge or whatever for shipping. So yes, it looks really good, but how much of a true impact is that going to have? I'm not going to tell you it's not going to have an impact. I want you to be the interpreter of that. Okay? Everybody's talking about safety. But do we actually understand exactly just how flammable this gas is? What does LFL and UFL represent? What's its relevance to us when we're in the field? So, let's get some definitions. LFL, lower flammability limit. It's the minimum amount required in a room by volume in order for this room to be combustible. So call this room 1,000 square feet, okay? Maybe 1,200, whatever it is. How much by volume in cubic footage would this room have to have in it in order for it to be a fire risk? But the relevance is even more important. We use that to set charge limits. Gone are the days where you can set it and forget it. If you're putting in a system, you now have to perform a formula. Technically, you have to perform a formula to make sure you are putting in a unit with a low enough amount of charge to service a large enough amount of square footage. Upper flammability limit is the maximum amount for sustainable combustion. Anything after UFL, the fuel to air mixture ratio is too rich for sustainable combustion. And it defines our flammability range. So let's talk about a few numbers. Let's use 32 as an example. 13.3% by volume. That means that this room would have to have 13.3% in cubic footage worth of refrigerant. That's a lot. And that's to reach the minimum point of where it's combustible, versus that of, say, R600 at 1.8%. Okay, isobutane. There's also R601, which is isopentane. Propane, 2.1, 1.8, far, far less. Okay, and the takeaway from that, again, is the moment you have an ultra-low, lower flammability limit, very, very little is required in that room for this room to be a ticking time bomb, okay? And these are higher flammability versus that of something that's a lower flammability. And on a chart, and I hope you can see the color contrast here, anything in orange, you're still not combustible. You have to reach this moment in time in order for you to reach the minimum. And then anything in the peach color, right, that's where you have your combustible range. And anything above that, your fuel mixture is too rich, right? So you look at 455, look at how small a sliver that is. Now you might say, well, hold on a sec, Kev, you said it's a narrower range. Look at R32. Yeah, but look at how high that lower flammability limit is. It's very, very difficult, and that's why these formulas exist, to make sure that your system can't leak enough to reach that level and put the occupancy or occupants of that room at risk, versus that of something that is much, much less here, but a very, very high range to continue to burn. Okay? How we class these gases is under ASHRAE 34, and many of you have seen this slide. This is a pretty popular slide. I borrowed it. Firstly, just a couple definitions. A and B, toxic, non-toxic, okay? Or forgive me, non-toxic, toxic, A and B. A1, 507, 404, 410, 407, A, C, F, 513, 134, those are all A1s. A2L, 454A, 454B, R32, the ones we've been talking about. A3, 290, 600, 601. B2L, for example, R717, ammonia, okay? And then you've got other ones in the B3 range like sulfur dioxide or ether or whatever the case may be. Top right, 410, class 1, you will see a flame. 410 is flammable. Not a lot of people know that. Everybody thinks, oh, 410, it's an A1, it's non-flammable. You told me it's not flammable. Yes, it is, under the right conditions. So Underwriters Laboratories, they do a controlled chamber with a timed flame propagation between these axes. How quickly does that flame propagate? How quickly does it spread? If it remains within the axes, it's a class 1. You go slightly outside of it, it's a 2L. You light up like the Griswold family Christmas tree, it's a class 3, right? But this contrast is what all the fuss is about. Doesn't look like much, does it? I got something better for you on the next slide. There's only a couple of degrees difference between the two here. Toasters, electric heaters, a lit cigarette. Don't smoke on the job. A lit cigarette doesn't have enough energy to combust this gas. It has to be open flame or spark. 410 is flammable under perfect conditions. And lastly, the sum total, because of such a close contrast between the two, safe handling is effectively the same. But we're going to talk a little bit about what we're going to do with transport law and things like that shortly. But everybody wants to see it happen, don't we? Right. So we're going to show you. This is a 60-second clip. This is a controlled lab setting at Underwriters Laboratories. Over in the right corner, you're going to see a PTAC unit, package terminal air conditioner. What we're going to do is we're going to piss gas in this room to the absolute picture-perfect conditions. And then we're going to do a forced ignition. Take a look. It's a 3-ton, Steve. Forced ignition. And just so we're clear, that igniter is on the bottom of this rack, not the top of this one. So it's right in the middle of that fuel mixture. Wow. That was Hiroshima. That is what the fuss is about, right? That's what the fuss is about, Brett, seriously. You just watched it in real time. That's Underwriters Laboratories. That's not a 2-bit testing agency. That governs everything. And you just watched the perfect mixture. I'm not sure if it was 454 or 32, don't quote me on that, but it was an A2L. I know the lighting in here would kind of compromise your view of it. There was a small little wave of a flame there if you have the right lighting or the lights were off, but ultimately, that's what your panic is about. So don't panic. And not only that, but in the fall, I'll introduce to you a lot about the leak detection systems, where the cutoff points are, sequences of operation, all the variables and operational performance numbers. You'll get a lot more technical detail. We just don't have the time today, okay? But one thing I will point out before we change slides, because we are going to talk about it in the fall, anybody see any refrigerant left? No. A2Ls have a very rapid dispersion rate, which is even a larger contributor to the safety of a limited flammable gas, okay? Takeaways, pretty simple, straightforward. Higher UFL, it's harder to sustain combustion, much more narrow flammable range in an A2L. In the case of a leak, it's much more likely to disperse or exceed upper flammability limit, thus and thereby we have too rich of a fuel mixture and it's not combustible, and obviously a much safer alternative than that of an A3. This is a very interesting section. Everybody has heard about it, everybody knows about it, few people have read it. If you suffer from insomnia, please get this book, it will put you right to sleep. I'm a very, very privileged member of the CSA B52 committee. I was invited on 18 months ago, so I am a newbie. But it has been a very high honor of mine to serve with the CSA folks and learn a lot about what is in the code book, what is forthcoming, and eventually make my way cover to cover. And it's important that we expose you to that too, because gone are the days where, again, you set it and forget it. So there's 6 major sections you need to be focusing on when reading the code, and each one of those sections will direct you to a different annex or appendix or subsection, and it will take you back and forth. The first is section 4.2, classification by occupancy. Very, very important. Every site you've ever worked on in your career has a classed occupancy. That could be commercial, industrial, specialty, lab, residential. Every one of them has a different set of rules. Now, there's a lot of overlap, but different sets of rules. Make sure you know what your class is if, in fact, you have to resort to the code book and understand what you need to do. The second, section 4.5, arguably the largest section. Granted, it's going to be the hub. These are all hubs, by the way. They're going to take you to different areas, right? What does your application require? Right? What do we need for valves? What do we need for pressure reliefs? Where are they going to be vented? Do we need ventilation? What do we need for leak detection? All the rest of it. 4.5, and it's so large, in fact, I've taken the liberty of putting it on the next slide for you. Section 5.5, design pressure is important for 2 reasons. One we talked about, copper, and the other we talked about, job registration. Right? You're going to need to know your new pressures of gases that you're otherwise unfamiliar with when you pull a P drawing out of the database or you're submitting one for registration. I know that a couple of you or folks within your organization are working on new drawings and updating that database. As a wholesaler, I thank you for that because I work very closely with TSSA and yourselves, and it's very, very helpful when those drawings are up to date. But you're going to need to know your new design pressures. 6.1, installation. So not what does the application need, but what do you need to do? How do we install this safely? Does it need to be away from anything? right? Do I need fireproof doors? These are going to be things you're going to start to have to ask yourself because, again, it becomes a little bit more complicated. Now, save that of a rooftop, for example, everything's outdoors. All the rules kind of sort of melt away. Residential, kind of sort of melt away. Large commercial split, chiller, rack in a mechanical room, these are the kinds of things we need to watch out for. There's icebergs in the water. Section 6.2 and 6.3, if you have a classed plant or you have a mechanical room, I think they used to call it a Class T, I think it was. Your machinery rooms have a whole section unto themselves to make sure you have a good understanding of what that machine room needs to be able to facilitate in order for an A2L to operate within it. And a lot of that's going to be predicated on the weights of refrigerant in the system as well. And lastly, 8.4, maintenance. Now, comically, if you want to call it that, a lot of 8.4 actually says refer back to the I&O manual of the manufacturer. And you will find that I&O manual has been updated. So you haven't seen it today, but in the fall I will show you. There is a formula this long that you need to perform to make sure you have a good understanding of the minimum square footage in the room and how to maintain your system. And the I&O manuals from those manufacturers have been updated to ensure that they give you cheat sheets on not only how to size and design your system, but how to properly maintain it. And arguably, the code book actually says refer back to it, giving that I&O manual a lot of power, right? So very, very important. This is section 4.5. We're not going to read through all this. Don't worry, I won't put you to sleep. But I do want you to look at two major sections on the left. It's actually more simple than it looks. Section 4522, or subsection 4522, because the real section's up here. Refrigeration systems for high probability human comfort. And systems for other than human comfort. It's pretty much your only two options when you really think about it, right? You do have this one down here for A3s and B3s. I don't know if any of you work with sulfur dioxide, but I doubt it. A3s, propane, well in Canada we're limited to 8 ounces or 150 grams, so chances are you're not going to be working much with that, although we are seeing self-contained systems in supermarkets now. I know a few of those manufacturers, Hill Phoenix, Hussmann, Arneg, they're being pretty creative with it. And on the right, you will see 454, system refrigerant charge limits and charge limit determinations. If you have a copy of this code, make sure it's a digital one, and I'll tell you why. Everything here, highlighted and underlined in blue, is a hyperlink, and I can click on it, and I go to that section code versus that of flipping back and forth, okay? Make sure you have a digital version, but you're going to see something very interesting. You're going to see some references to 7A and 7B, 7A and 7B. There's going to be a lot of that throughout the code book. And when it was being authored, we wanted to make sure we came up with a very handy-dandy chart for everybody, right? And I say we, it wasn't me. I walked into it, and I thank the folks that allowed me to watch it unfold, but I really had nothing to do with this. This is a step-by-step guide. We don't have enough time to go through it today, just in the interest of time, but you would start up here, and you actually read, you know, is this a certified piece of equipment under 6.6 pounds? And okay, no. And is it self-contained and located in a commercial occupancy? No. And okay. And then you go yes, no, yes, no, yes, no, or it takes you to 7B. But this is the first time we've actually had a bubble diagram that permits us to walk through something with relative ease versus that of the complicated last 2 pages I just showed you, okay? But again, if you get a copy of the code book, please get the digital version. No, you can't share it. I'm not saying that because I'm on the committee. I'm saying that because it's encrypted to your computer when you buy it, right? So you can't share it. Okay, getting towards, we're third last section here, so we'll speed it up. Anytime we come out with code, it comes out every 5 years. Those of you remember, 2018, it was 2013, 2008 before that, so on and on and on. That's just the code, but it needs to be adopted, right? Every provincial regulator, ABSA in Alberta, TSAS in Saskatchewan, TSBC in British Columbia, TSSA in Ontario, they need to adopt the code. and perhaps specific segments of it. Just so you're aware, without that adoption, right, it's not worth the paper it's printed on. TSSA won't acknowledge it, right? The OBC, the Ontario Building Code, won't acknowledge it. It has to all kind of go hand in hand in order for it to be adopted. This is our current status in Canada. I did some research this morning. I tried to see if I was going to lie to you today and see if Nova Scotia has not been adopted. Any East Coasters that can correct me if I'm wrong on that? I tried. Jim, I know you spent some time out in the East. Do you know if it's been adopted, the B-52?
Not as of January, February, I'm not sure.
9.8, much, much less than that of, say, a 10-kilo drum of an A2L. Everybody's vehicles look like that, right? Absolutely, right? Okay, good. So, everything you carry in your service vans falls under Class 2. Everything. Your nitro, your oxygen, your acetylene, your argon, your A2Ls, your legacy gases, it's all under 2. It might be a variation of 2.1, 2.2, 2.3, 2.4, 2.5, whatever it is, but it all falls under the TDGR, Transportation of Dangerous Goods Regulations, okay? And it's federal. It's not controlled by the Ministry of Transport of Ontario, okay, or any other province for that matter. It is under Transport Canada. Under Section 115, and you can look this up, this is straight from the government, there is a 150 kilo gross mass exemption. Very important. You can carry your A2Ls up to 150 without the need for placarding, without shipping documents, without hazmat, basically as you were. No changes, provided that you meet the CSA standard, which the tanks do, right? And small means a contaminant. In other words, don't put propane in with refrigerant. I see the reports. I know you all cross-contaminate gases in your reclaim cylinders when you return them. Don't lie. I know you do. But it has to be 46 liters or less, right? That elicits a little bit of a concern, doesn't it? Because what about squat tanks? So let's just go through some quick math. The tare weight of a standard 30-pound tank is 13.6 kg, right? That's the standard weight of an empty tank. 9.5 kilo is what you're going to have in terms of A2L content weight inside, giving you a gross mass of 23.1. If we use the 115 exemption, that allows you 6 cylinders in your truck. Now, if you were to pull out your calculator and do that math, it actually comes out to about 6.5. But I say 6 because you have to include all the gases that you have in your vehicles. So it's really, really important that we follow this. But let's say you had a big job and a big project, and I need to carry more. 116 has a 500 kilo gross mass exemption. The difference, the main difference, the driver must be hazmat trained and has to have the certificate with him or her at all times. Please make sure you do that. Now, same provisions apply here. The other one I'll mention briefly, any leak, tampering, loss of tank, whatever it is, it must be reported. This I'm not sure on, and I've done a lot of research and I can't get a clear answer. It says you may need to register with Transport Canada. I don't know. Please look it up yourselves. I can't figure it out, and I wasn't going to wait on hold for 4 hours at 1-800-O-Canada, right? But very, very important you look that up because you may need to register. The good news is you're not going to need to make a whole lot of changes in terms of what you're used to. Last section, because we're pretty much right on the button right now, and it's only one slide, so don't worry, is tools. For any of you under the illusion that your tools will not change, they will. However, full disclosure, it's not a law. There's nobody in this room that wants to sell you more tools than I do. But your tools will change from a safety perspective. It's highly recommended, but it's not a legal requirement. Very quickly, to cover the recovery cylinders and the virgin tanks. The new virgin tanks will be white in color with a red stripe around the top. Some manufacturers have opted into painting the top cap and handles red, so like a red bonnet on it. You'll also see a 2.1 diamond hazmat placard, similar to that what you see on the local gas truck delivering gas to your local gas station. So you're going to see some labeling from hazmat there. Vac pumps, and I'm going to use a Yellow Jacket bullet as an example. The 93600, it's a little 6 CFM thing. It's very popular. It can't be used. Why? It's an open motor. You can have a spark between stator and armature. And even though you could argue, well, it's only vapor going through that, what risk do I really run? Do you really want to take that risk? Do you really want to speculate? Probably not. Thankfully, a lot of you already have the right vac pump, so you may not need to make any investments at all. But sum total, you need a totally enclosed motor, right? Recovery machines, same thing. Now, I've talked to a few manufacturers about this. They have talked to me about grounding that unit. There's some static buildup on that unit. We know the compressor's sealed, but there is a fan motor. They've made some alterations. For those of you who are interested in doing a new recovery unit, please look at the date code on your machine. Anything from what I've been told post-January of 2022 should be okay. Should be. But please confirm with that manufacturer or from whomever you purchased it from. We're not going to talk about room detectors. Handheld leak detectors, okay? I put my personal favorite up there. You do what you will. That's the Inficon 550 Stratus. I promise you, if you want to spend the money, it will be the last handheld leak detector you ever buy. The beauty of this is it has interchangeable cartridges. Not all sniffers have the ability to do A2Ls or HFOs out of the box. It may be restricted to HFC or HCFC or CFC, okay? This has interchangeable cartridges. Out of the box, it has the silver cell. That's good for HFC, HFO. You can buy the natural refrigerant green cell, which is the CO2, R744. It also is compatible with R290. So if you're going to make the investment, I'd rather you not buy 2 or 3 leak detectors to do 2 or 3 different families. I'd rather you spend the money on one and have interchangeable cartridges. I'll address gauges as the last point of action here. For those of you in the room that are on the tools, most of you are kind of looking after the folks on the tools, but for those of you who still have technicians on your team with analog gauges, they will change. If you're digital, you're safe. Likely, they've already been updated. You've got a list of refrigerants on it, usually about 70 to 75 or so on a digital manifold. If it's analog, the dial will change. Okay, it will be out of calibration. Please go and buy a new set of gauges or a new manifold. The last thing I will tell you that isn't on this is your yellow hose. Your tying on to refrigerant tanks will be quarter SAE left-handed thread. If you don't want to buy a new yellow hose, buy a half a dozen adapters or a dozen adapters. They come in 45 or straight. The last thing you want to be doing is having a technician frying his ass off on a July afternoon on a black tar roof, and I can't tie onto my tank. Bad news. Please go and get the adapters. If you do run into a tank that has a right-handed thread, there's been a valve shortage and a tank shortage thanks to the US. Manufacturers are doing whatever they have to do, okay? I will put for any, I know most of you, but for those of you who I haven't had the privilege of meeting, my name and number is up there in case you do have any questions or concerns. You can email me, call me, whatever the case may be. And just because I always do a sales plug, we do offer no-cost trainings in a broad spectrum of different segments of the business. We always would love to have you, and we invite you to join us. We don't believe in charging for that education, but we do believe in being active participants of the community.